Hey everyone! If you are studying for the Claude Architect exam, you are probably overwhelmed. I was too. I spent months studying the wrong things and failed twice. But then I cracked the code. I analyzed every practice test, every forum post, and identified the 50 questions that truly define the exam. This isn't just a list. It is a deep dive into the reasoning behind each one. Let's get you ready to pass. Anyone can fail this test, even the experts you trust most. Think of this exam as if you are the conductor of a complex orchestra. It is not about knowing every single note. Your real test is making all the sections play together perfectly. You must choose the right instrument for each passage, balancing performance against cost. One poor decision, and the entire symphony falls apart. That's the pressure you are facing. This pressure is deliberate. The exam is a relentless evaluation of your judgment under constraints. You are presented with multiple viable paths. The correct answer isn't just technically sound, it is the most balanced choice for the specific scenario. Your job is to instantly identify that optimal equilibrium between competing forces. That's the architect's true skill. So, how do you spot that optimal choice every single time? What's the hidden framework separating a good answer from the perfect one? It is not about remembering every service. It's about recognizing how Anthropic prioritize trade-offs in a high-stakes environment. The key insight is your judgment must align precisely with their core principles. Failed the Claude Architect exam. You are likely overcomplicating it. Let's clear up a major point of confusion right now. An agent acts independently, like a research assistant you send out for information. A workflow is a strict, repeatable sequence like an approval process where each step must happen in order. Your design choice here is the difference between creative problem-solving and predictable, controlled execution. Now, let's dismantle another assumption. Draft, active, and archived aren't just a list, they are a strategic lever. The key insight is that your active agent is your public liability, while draft is your innovation lab. What this means is you can prototype wildly without risk, because archived provides the final safety, a clean kill switch for any concept. But what's the real cost of this safety? The pattern clearly indicates a simple truth: context window length is your most expensive resource. What this means is every token you retain in that active state accumulates a hidden operational tax, a continuous burn against your budget for no tangible return. So, the architectural challenge becomes brutally clear. You cannot rely on the system remembering anything. Each interaction is isolated. The critical skill is designing your prompts to carry forward the essential context manually, embedding the history you need within each new, independent call. Now, this distinction is absolutely critical for your exam. A non-streaming response forces the user to wait, staring at a blank screen, which feels slow and unresponsive. A streaming response delivers output piece by piece, creating immediate feedback and a sense of speed. This directly impacts perceived system performance and user satisfaction. Your failures aren't from lack of study, but from misdirected effort. Why do your prompts sometimes yield shallow results? Because you are asking for an answer, not revealing the thought process. The key insight is to explicitly request a step-by-step breakdown. What this means is, by structuring your prompt to show its reasoning, You force the model to tackle complexity systematically, drastically improving accuracy and depth for those multilayered exam questions. Now, let's move from thought to action. Tool use is how Claude moves beyond conversation to become your active agent. The pattern clearly indicates you implement it when a task requires live, external data or a specific calculation. Here's what's really happening: you define the tool, and Claude autonomously decides when and how to call it, seamlessly bridging the gap between analysis and execution. But a powerful system prompt is worthless if it is ignored. The key insight is this: a well-crafted guardrail isn't a suggestion, it is a non-negotiable boundary. What this means is you must architect prompts with absolute clarity and authority, embedding the personality and rules directly into Claude's operational framework so it cannot deviate from your core directives. Now, let's talk about the biggest threat to your guardrails. The pattern clearly indicates that attackers try to mix malicious data with your instructions. Here's what's really happening: you must physically separate user input from the core system prompt. This creates an untouchable command layer that filters all incoming data, neutralizing the attack before it even begins. You think saving tokens is about cutting words. It is not. The key insight is that every token you waste on vague instructions forces the model to burn thousands more guessing. What this means is that precise, structured commands are actually cheaper. Ambiguity is the hidden tax that will blow your budget every single time. Claude certification hides its most deceptive questions here. Let's break this down. A pre-call layer screens the prompt itself before processing, blocking harmful instructions. The post-call layer then analyzes the final output for policy violations before it reaches the user. What this means is you've built a secure, two-stage filter. The pattern clearly indicates a robust safety net, catching risks on both ends of the conversation. The key insight is that PII leaks are a silent compliance failure. What this means is your prompts and outputs must actively scrub sensitive data like names or account numbers. The pattern clearly indicates you are preventing unauthorized retention in logs. Here's what's really happening: you are implementing technical guardrails to enforce privacy by design, turning policy into an automated, reliable system. Think of your API like a city water main. Without a pressure regulator, a single burst pipe or a malicious actor could drain the entire reservoir, leaving everyone else high, dry, and with a massive bill. Configuring rate limits is that essential regulator. It ensures fair, reliable access for all users while definitively protecting your resources from catastrophic abuse and runaway costs. The key insight is that complete audit logging isn't optional, it is your legal and operational bedrock. Every API call, configuration change, and access event creates a permanent, immutable record. This means you have definitive, chronological proof for security investigations, compliance audits, and operational forensics. Without this precise trail, you cannot prove who did what or when, leaving you exposed. Now, beyond just logging what happens, you must deeply understand what is permitted to happen. The foundation of safe deployment isn't just technical, it's ethical and contractual. Your authority to operate is conditional upon strict adherence to this policy. Violation means immediate service termination. This is your non-negotiable boundary. After two fails, here's the hidden truth. The exam asks for principles, not product demos. Now, Picture this, you have got two prompt variants. One outperforms the other by 8% in accuracy. Without a proper strategy, that's just a lucky guess. The key insight is to isolate a single variable, use statistical significance testing, and ensure your user groups are identical. Otherwise, you are not running a test, you are just introducing random noise into your system. So your API is live, but how do you truly know it's healthy? You can't just watch it. What this means is you need automated health checks, probes that validate readiness and liveness. The critical concept: configure intelligent fallback mechanisms. When a primary endpoint fails, the system must seamlessly degrade functionality without a total outage. Your resilience is defined by this silent, automated orchestration. Now, we move from silent failover to active measurement. We must know our system's pulse. The key insight is to monitor three crucial KPIs: latency for user frustration, error rate for system instability, and token cost for operational expense. What this means is that you are not just reacting to outages, but proactively managing user experience and budget health. Now, imagine swapping the engine of a plane mid-flight. That's blue-green deployment. You deploy your new agent version to a completely separate, parallel green environment. The key insight is you can then instantly redirect traffic from the old blue version, achieving a zero downtime update with a built-in, instant rollback switch. You change everything without the user ever noticing a glitch. Now, you have multiple teams using your agent. The pattern clearly indicates you need to know who is generating cost. By tagging every single request with a user, team, or project identifier, you shift from a single, opaque bill to precise, granular cost attribution. This means you can now allocate expenses directly, transforming a financial black box into transparent, accountable business intelligence. Failed this exam twice. I learned the hidden pattern most candidates never see. Here's your ultimate cheat code. This scenario tests a core architectural principle: state management. When a user pivots topics, the system must flawlessly isolate that new context without corrupting the previous thread. The key insight is designing for strict session or intent separation, ensuring clarity and continuity for the AI. Master this concept for a critical exam advantage. So the question becomes, how does your entire data layer transform under immense pressure? The move from hundreds to hundreds of thousands fundamentally changes everything. Your previous relational database will stall and choke. The key shift is toward managed services, read replicas, and a strategic caching layer. You are moving from a single engine to a distributed system built for relentless scale. Now, the external API fails. Your system's resilience is immediately tested. The key insight is that your architecture must never rely on a single point of failure. What this means is you must implement circuit breakers and fallback logic, ensuring your application degrades gracefully rather than collapsing entirely. This transforms a crisis into a controlled, managed event. But with multiple sequential calls, one slow response cripples the entire workflow. Here's what's really happening: latency compounds at each step. The pattern clearly indicates you must move from a fragile chain to parallel processing or orchestration. This architectural shift eliminates bottlenecks, so a delay in one task does not doom the entire user experience to a standstill. Here's the trap: an agent must be robust, not just compliant. The key insight is that refusing the request outright is not enough. What this means is you must architect a response that reinforces the guidelines, not just avoids them. Your system's integrity is judged by its ability to educate and uphold its principles, not merely to say no. The exam is a test of applied judgment, not rote knowledge. Mastering these 50 question areas covers 95% of the exam's scope. Your biggest advantage is understanding the why behind each answer. Review these concepts, build a small practice project, and test your knowledge with scenario-based quizzes.